Potentiometer is a device which is used to measure the potential difference across any 2 points in a circuit, or it is also used to measure the value of EMF. See, many students confuse this potentiometer with meter bridge. Meter bridge is basically a instrument which is used to measure the value of unknown resistance or of any wire, and it usually consists of only one wire of 1 meter. Here in potentiometer we have extended version of wire. Basically here also we are dealing with one wire only, but this is the extended version. So the accuracy or the way we make out the measurement from this is more accurate, right? So this is the wire in case of potentiometer. What is the driver? Where is the driver cell? Here. First of all, a switch, then the battery or the driver cell of the circuit, make it variable, then it is connected with rheostat. This is how potentiometer circuit is made. Now, what is the working principle behind potentiometer is, see, do you guys know the term potential gradient or just the word gradient? Gradient means any physical quantity which is divided by length. For example, in electrostats also you did studied about potential gradient, that E is equal to minus dV upon dr. So the statement for this expression was electric field is negative of potential gradient. So gradient is basically physical quantity divided by or divided by with the distance. Well, I will just tell you what is this negative sign here, because it comes in the 1 marks question, so it is important. The negative sign shows in this expression that electric field is in decreasing direction of potential. That means the direction of electric field is towards the point where potential is decreasing. Anyhow, coming back to our topic, potentiometer. See the principle. If I connect a voltmeter here and this voltmeter is connected with jockey. Jockey is a metallic conductor which is used to make the connections in the circuit, right? So if I connect the jockey here, so this voltmeter is actually going to give me the potential drop or potential difference between this point and this point, right? This is what the function of voltmeter is. So principle, look at the principle. What we are finding out, we are finding out voltage or potential difference, but what do we have in the circuit? We have a constant current flowing in the circuit, right? We also know the formula V is equal to IR. If I expand the term R, I have rho L upon A, which is R into I, right? This was the formula of R. Here, how many things are constant? Resistivity is a constant, current flowing is uniform and constant because we have fixed the value of voltage and the resistance. Area of cross section is also constant. What might be changing here? If I change the value of, or if I change the position of jockey, I will be getting different values of L, right? That means V here is V is equal to a constant, that is rho into I upon A. This is a constant times L, or you can write it V is K times L. This thing gives you expression that V is directly proportional to L. This is the basic working principle behind potentiometer, that voltage drop across any part in the potentiometer wire is directly proportional to length of that part of wire. Or in other words, what is potential gradient? Potential gradient was voltage divided by the length. So if I take this L here, I will get V upon L is a constant. So this is also a principle in different books. Some books they use this formula, some book we have used this formula. According to this formula, the definition of potentiometer principle would be that potential gradient per unit, potential gradient of a wire is constant, that is potential drop per unit length is a constant, and here again potential difference is directly proportional to length. So anyhow you can state the principle. What are the applications of potentiometer? Potentiometer is basically used to find either the internal resistance of a cell, number one, or it is used to compare the EMF of two different cells. See how do we make it. if I have to compare the EMF of two different cells, the construction changes like this. With this wire, I made two connections, one here. This is cell E1 and another cell E2. Switches and then the jockey, which is connected here. For example, if I take, what is this jockey representing? Where is the voltmeter? Where is the galvanometer? See, here we have a galvanometer. So if the galvanometer reading is 0, that means this point, whatever this length might be from here to here, that means this length plus this length. This complete length L is actually showing the null point for the cell E1 if I am taking E1 in the circuit right now. If I take E2 in the circuit right now, so the null point will be showing the voltage which this E2, the another cell, is balancing across this length. So this is how, now you got the idea what is the principle. See, if I move this jockey, whatever voltage is being dissipated or used or dropped across this length is ultimately going to balance this voltage somewhere in the circuit, right? For that, the driver cell has to be greater than the values of E1 and E2. So this is one of the major point which you should remember while doing the numericals of potentiometer, that driver cell is always greater than these cells. What will happen if E1 and E2 is greater than the driver cell? Potentiometer will not work. Simple. Because the overall voltage was initially divided among the whole wire. It was uniformly distributed across the wire. So to obtain the null point given by E1 or E2, you have to have that much potential in the wire which can be measured or across which a null point could be obtained, right? So continuing this with this topic, suppose with E1 we have a null point at L. So we can say that according to principle of potentiometer, E1 is directly proportional to L, or let it be L1. That means E1 is equal to K times L1, and for E2 is directly proportional to L2. For example, if I am getting a null point somewhere here which is L dash, or let it be L2 for cell E2. So E2 is directly proportional to L2 where the null point is obtained or balance point is obtained. So E2 is equal to K times L2. If I divide these two equations 1 and 2, what do we get? E1 upon E2 is equal to L1 upon L2. So this is how we compare the EMF of two cells, right? There is another application of potentiometer which is finding the internal resistance of a cell. For that, what do we need to know? Do we know the concept of what? Internal resistance? Yes, we already have discussed that point. What is internal resistance? It is the resistance which dissipates a small part of power of a cell, right? And that is why EMF is the maximum potential difference across the terminals of the battery when cell is not in use, while the potential difference is the maximum voltage it can deliver to the output circuit after dissipating some power in the internal resistance, right? So here we have a cell having EMF E1, because I am not using the term E because E I have already stated for the driver cell. I have a cell E1 for which I have to obtain the value of internal resistance. If I connect this cell right away like this and the balance point is obtained across L1, what am I getting right now? I am getting that value of voltage which is balancing in this much length, right? So what about internal resistance had to be taken care of? For that, what do? We put another resistance here with a switch which is not connected right now, and it is connected in parallel with this cell. Now if I connect the switch, if I switch on the circuit or in other words if I close this circuit, what will happen? This time what the balance point will be showing me? The balance point will be showing me the value of potential difference of this cell, not the EMF. EMS was without internal resistance, but right now what voltage is going, cell is connected with an external resistance, so that means whatever voltage R is getting is the potential difference which E1 is giving, right? So this time the balance point is going to give you, now suppose this balance point is here, which is L2, the balance point is giving you the value of potential difference which the cell can give, or the maximum potential which it can give. So this is how you will write. E1 is directly proportional to L1, which implies E1 is equal to K times L1, and V, what V? The potential now. V1, because in second case we closed this circuit and we took R into consideration, so this time we are getting the potential of this cell. V1 is proportional to L2, that means V1 is equal to K times L2. Now divide both, you will get E1 is equal to, or E1 upon E2, this K will cancel out, is equal to L1 upon L2, right? How, sorry, there is a mistake, this is V1. So now, so how are you going to relate, where do we put internal resistance into picture right now? See, what is E? EMF is the maximum potential difference which it can offer. That means current into maximum resistance. What is maximum resistance? R plus R. And what is voltage? Voltage is just IR, right? This is equal to L1 upon L2. So basically this is the value of E and this is the value of V. Cancel out I. By this equation, R plus R upon R is equal to L1 upon L2. You will get the value of internal resistance of this battery, right? This is how we use potentiometer.